Welcome to our podcast series for the City Quantum and AI Summit. I'm Paolo Cuomo, the co-founder of Quantum London, and really delighted today to be speaking to John Hammant, who is, I guess, just a sort of broad high-performance computing expert, and really looking forward to hearing your background, John, in the space and what you're doing in the context of your day job and what you look forward to talking about at the summit itself in October. So yeah, let's dive straight in, please. Tell us about your background and how you got into the quantum and AI space.
Yeah, by all means. Thank you so much for having me. It's an absolute pleasure. So my background personally, so I've been into tech from a very, very, very young age. So back, I think I got BBC Micro when I was 3 and started programming BASIC on it a very, very long time ago before getting into the Amiga and all kinds of fun things of bulletin boards and the web prior to the web existing. Currently, I'm leading the specialist team for Amazon Web Services for the UK. So effectively anything that's either technically difficult, slightly special, non-standard, large, interesting, all rolls up to me. And as part of that, I run both our artificial intelligence, machine learning, but more importantly for this discussion, all of our high-performance computing and our quantum computing businesses. Prior to this, I've been with Amazon for 4 years. Prior to this, I was running the computing business for the UK and then the compute business for all of Europe. So that was, bunch of fun different things, from everything on EC2, our elastic compute cloud, over into all kinds of fun, interesting bits of high performance computing, autonomous vehicles, autonomous systems, low powered flexible computing, and quantum computing, which is part of this. In terms of how I got into all of this, I'm definitely a science nerd at heart, I think would be fair to say. I'm very, very dyslexic, which is a really good thing for me. So I couldn't spell my name to fully till I was 11, but I got my GCSE information systems at 11-year-old, A-level computer science at 12-year-old, and just fell in love with physics basically from as young as I can remember. In terms of the world of quantum, I think it's really interesting when I look at some of the complex and interesting challenges that our customers are trying to fix. I think quantum computing will be absolutely key to some of those solutions. You can see the exponential usage of computing that's coming through everything from machine learning to drug discovery to chemistry to all these kind of really fun things. And so many of those are problems that I think are really applicable to being solved through the power of quantum computing.
Perfect. And when you talk about customers, these are large corporations, either small businesses. What is the range of customers that are interested in this?
Yeah, definitely. So I mean, so one thing that always amazes me, some people aren't necessarily always sure what AWS or Amazon Web Services does. So I can briefly explain that because it always helps. When people think of Amazon, they think of it being the shop that turns up and, for me, it seems on a daily basis, seems to deliver things to my house that I've been purchasing. But Amazon itself, one of its largest businesses is Amazon Web Services, which effectively provides infrastructure on demand, hosted in a remote environment, hosted in the cloud. And that can either be down to a level of the infrastructure itself or to services on top of that. With quantum computing, it's one of these things, as much as, we see people building data centers still, even though that's all kind of moving back slightly, it's very likely that people that use quantum computing aren't necessarily going to host and run those systems themselves. Or at least that's definitely our belief. So where Amazon comes in within this is this democratization of the access to quantum systems. We've got a huge variety of different quantum technologies running in AWS at the moment, and those are all through different kinds of quantum machines themselves, whether that's annealing or a whole vast variety of different things around it. We've got Quantum Solutions Lab. But the major thing for us is enabling people to come up and actually spin up things like quantum computing. For people listening to this, is one of these really fascinating things that I think there's very few times in the early days of computing that you could just go on and you could actually use those kind of cutting edge systems in the way they are. But that's something that we allow everyone to do, both large and small. In terms of the customers that we engage with on this, it's everything from, we've got blog posts out there from the likes of Fidelity. We've got some interesting ones from one of the Italian nuclear physics laboratories. We've got different things from quantum chemistry, if we look from Pascal and how they've put things through that as well. But it's really across the whole gamut. I do genuinely think that quantum computing is going to really start to transform the world. And I think the more that companies can at least have some experience with it and start to understand what those problems are going to be and what those use cases are going to be far in advance. And we see those ones who are probably going to be the most likely to do interesting stuff with it.
Oh, yeah, and just sort of to play back a little bit of that. So, you mentioned having a BBC Micro once upon a time. You had to buy that, you had to own it. Corporations, when it came to mainframes, needed to spend a huge amount of money and put it in the basement. Effectively, what you're saying is you're able to invest in these technologies and the R&D and have them, but the company that wants to use that computing power is simply connecting to you in the way that they would any normal computer, so to speak.
Exactly that, and I think that's one of the interesting things that is going to help drive the revolution in quantum computing. And more broadly, we often talk about heterogeneous computing. So if I look at the computing landscape at the moment, for a very, very long time, x86, whether that's Intel or AMD, has kind of won the computing game. What we're now really starting to see happening very, very quickly is almost this diversity of compute. So thinking about running the right workload on the right system. And that's been something that previously, if you had to purchase those systems on-prem, on your own cache, it became very, very difficult to do. You had to have such a wide variety of it. It made it kind of difficult. But the fact that if you have an algorithm that's best suited to a quantum machine, and even a very specific kind of quantum machine, the ability to go and just pay for literally the minutes or the seconds that you use of it is absolutely game changing. And that's where we see this all coming. So it means that as an end user, you can experiment with it. We would, if I'm completely honest with you, I think other than some of the national labs, it's very difficult to effectively justify the purchase of an outright system that you're going to have on-prem. Where we think the cloud provides an absolute unique part of that is that you can come on, you can use it, you can test different systems, you can test the output, you can see where that relates to classical systems as well. So we've open sourced a hybrid machine learning library called Penny Lane that helps use both quantum computing and traditional computing together. But we think this ability to experiment quickly for really, really low cost is one of the things that we think is going to help change the IT industry.
And how much do you sort of simply supply the hardware? So if someone wants a minute or a second or whatever, it's there, versus so to speak, hold their hand through the process of identifying the best way to work with these hybrid machines?
Yeah, that's a really good question, actually. It's kind of a mixture of the two. So, one of the things that we like about AWS, you can literally go on today, you can sign up an account, and you can spin something up in a quantum machine this afternoon, or possibly even shorter than that. We have a relatively large team that will work with different specific people. So if you are looking at doing one of these things, we are really here to help. So it's either reaching out to myself or some of our quantum experts. What we're trying to do effectively is help build these products together with customers jointly to try and work out what the impact of them. We do a lot of that through our quantum solution labs. We've got a different AWS Center for Quantum Computing as well, which is where we're looking at how you solve real world business problems around it. And then we're also increasingly looking into quantum networking, which is something that we think is going to be really interesting, both from a data transfer perspective, but more than that, being able to have multiple quantum processors or QPUs effectively in sync over geographically large distances, which personally I think is one of the ways this is all going to go in the future.
That makes sense. And as we talk about the future and the commercialization and how your clients will be using this to make money, there's a whole range of topics that we'll be talking around at the summit. But what are the sort of 2 or 3 maybe that most interest you?
Yeah, I can definitely say that. So I think it's the ones where if you think fundamentally about quantum, it's this ability to take advantage of the exponential scaling that comes through adding an additional qubits on it. If I look at where some of the really interesting problems are at the moment, machine learning is definitely something where we're seeing increasing impact. I don't think we've cracked it yet, if I'm totally honest. I think there's been really good work in the system. I'm going to be talking with Multiverse. I think they've done some very, very good stuff around some of the algorithms. But if I look at the future, I think that machine learning using quantum algorithms is going to be a really, really, really interesting direction that comes in. If I look at the some of the other things that I'm genuinely excited about, chemistry is something that just absolutely blows my mind. I don't think people quite realize the ability to simulate things in an accurate manner, where you can start to simulate each of those interactions on a quantum level, opens up so many different possibilities. And it's really interesting if you think about penicillin, for example. And apologies, I should have checked this before, so I'd make sure I get the numbers right. So penicillin as a molecule, I think contains roughly 10 to the power of 83, I believe, quantum systems within it, which is a huge number. And to try and simulate in memory or do anything with it is just uncalculable, which is amazing, even for something that's very, very similar without interactions with other jobs. When you suddenly go into quantum, into relatively stable systems, you start getting to points where with 100 qubits, you can do really, really useful things in terms of both the simulation of the molecule themselves and of the pieces around it. So it's that bit that I think will change the world massively. I think it's interesting as well, if you look at scientific discovery previously, a large amount of it has been kind of luck. Like, I always find the discovery of stainless steel, for me, is one of my most favorite anecdotes, where effectively, there was a lot of work was going into looking at new gun casings, and it was just pure luck. It was literally trying lots of different alloys, lots of different amounts of makeup of those alloys, until eventually, luckily, we found one that with chromium and some other stuff in it that effectively, has changed the way that every time you eat, you don't taste metal, which sounds like a weird thing, but actually is pure luck that it's happened. And I think one of the things that really excites me about quantum computing is that ability to simulate things that we just couldn't simulate at scale before. So, thinking about everything from drug discovery to looking at what proteins fold in, to looking about how we build new materials and new elements that effectively, or new alloys, I should say, which will help effectively change the world in really positive ways. It's super interesting. And then on top of it, doing all of that in a way that requires drastically less power, I think is really, really interesting for the future of humanity.
Fantastic. And that, it sounds like is pertinent to a whole range of industries. So, clearly the pharmaceutical industry, other organizations that have big R&D teams. I don't know if one of the themes that sometimes comes up is, for example, battery technology and how maybe that can be modeled. Is that one that your clients are looking at?
Yeah, I mean, we see so much movement in this area in general, that I think that chemistry side of it thing is going to be that. We talked with one customer recently that was really interesting about carbon sequestration as well, of how do we start to pull CO2 out of the air. And I think there's a few, I do think we're in a really, really interesting time of history because of the leap that we can get through using quantum computing. And then, taking that as well with some really other interesting stuff that's happening at the moment in terms of space-based manufacturing, which is happening far more than it used to. I think it's going to be amazing. And I think all of this, the fact that you can access it cheaply, easy, pay by the minute against it, that's really where it's all going to change.
Fantastic. So maybe as a closing thought, linking back to your early point on BBC Micros and the such like, are we going to see the sort of young programmers of tomorrow actually accessing quantum computers via the AWS cloud in just a few years' time?
I would 100% say that's where we're going to end up with. And I think where it's going to get really interesting is not just the use of quantum, but the use of all of these new heterogeneous computing technologies. I think in the same way that when you go on and you put the right fuel in your car, you put the right things into what you're using, I think increasingly the IT landscape is going to change from where it's been for a very, very long period of time, that you have lots of identical. I remember going to data centers and you see just thousands and thousands of identical servers going through for that one customer. I think increasingly what's going to happen is everyone is going to use unique pieces of IT, whether that's specific instances of GPUs or CPUs or quantum computing, but using that right tool for the right job. I think quantum computing is going to open up massive, massive possibilities for so many different customers. And I think, for people that actually can work this out early, can get on that beginning piece of innovation, it's really, really key. You see the funding and the investment that's been going in both on a nation state level, and by private companies within it. And that's something that really, really excites me, of the impact that can have to all of our lives.
Fantastic. John, really great to speak to you. Looking forward to hearing from you more at the summit itself in October. Thank you and have a great day.
Brilliant. Thank you. I can't wait.